everyone. My name is Soham Gajare, a final year BTech student from Department of Data Science at J.H. Raisoni College of Engineering and Management, Pune. I, along with my team member Vishal Dhumal, have developed a project titled Automated Facial Sketch Synthesis for Investigations using Generative Adversarial Network (GAN). This project is completed under the esteemed guidance of Professor Rupali ma'am, Professor Masira Kulkarni ma'am, our HOD, Dr. Deepika Azalkar ma'am, and our project coordinator, Professor Rupali ma'am. In this video, I will give an in-depth overview of our project, the methodology, and finally showcase the complete implementation along with final predicted results. Let me explain the idea behind our project. Traditionally, in criminal investigations, forensic artists create hand-drawn sketches based on eyewitness descriptions. However, this process has many limitations. It depends on skill and interpretation of the sketch artist. Process is slow, manual, and not scalable. Inaccurate sketches may lead to misidentification of suspects. To solve these issues, we propose an AI-based solution that uses generative adversarial network to automatically generate realistic facial images. The primary objective of our project is to turn hand-drawn facial sketches into clear and realistic images using PatchGAN, a type of pix-to-pix GAN, and other generative adversarial architectures to train image quality and improve the generated images. The project aims to improve image quality compared to existing methods. System will evaluate how close generated images are to real using metrics like structural similarity index measure, peak signal to noise ratio, and feature similarity index metrics. Our project, our poster, the scalability section highlights the system can generate results quickly, even for some large datasets. It adapts to diverse demographics and varying image qualities, suitable for cloud deployment and can integrate with police database. Now let's come to the part of the methodology. Our project is based on generative adversarial network, especially a pix-to-pix inspired architecture. So generative adversarial networks helps machines to create new realistic data by learning from existing examples. The system consists of two main networks, generator and discriminator. Generator creates the realistic face from the sketch and discriminator checks whether the generated images is real or fake. Both networks continuously learn from each other through a feedback loop. The architecture uses UNIT for generator and PatchGAN for discriminator. This combination helps generate high resolution and detailed results. Automates facial forensic sketches creation, minimizing human dependencies. It can integrate AI-driven synthesis with existing police identification systems. Now I will explain the implementation that we have performed in Google Colab. Please follow the screen as I explain the steps. So starting, first step is setting up the environment. Here we have imported required libraries such as TensorFlow, Keras, NumPy, OpenCV, some image similarity measures, which is based on evaluation metrics. These help in deep learning, image processing, and visualization. Loading the dataset, we have loaded a paired dataset that contains sketch images and correspondence detailings that teaches the model how to sketch maps to real face. Now the third part is a pre-processing. Here the all images are pre-processed by resizing, normalizing pixel values, and performing augmentation. Here augmentation is done, pre-processing is done using the CV2 library. It is important to convert the images into tensor format that can easily be drawn in the generator phase. Tensor can easily adapt the images. Loading and augmenting of the images sketches are happening here as we are flipping, rotating the image as per the requirements of the generative phase. Here a sketch image is being imported as shown. The fourth part is building the generator phase and discriminator phase by using the building blocks downsampling and upsampling, which is required for the unit architecture. Here you can see the unit architecture, encoder part, bottleneck part, and the decoder part of the system. And the final part, as the unit architecture is done, this type of layer is showcased. Functional 11 level model is showcased as an input layer, sequential layer, and different types of parameters are drawn here. Here from this image, you can easily understand the unit architecture, that input layer, sequential layer, and concatenate layer. Here the phase bottleneck you can see, and this is the decoder phase of the unit architecture. Here are some training loss and optimizer functions we have used for better learning rate and better model checkpoints. Can use the best model Keras model. This is the learning and training phase of the model, where we have used 50, where we have used 25 epochs early with a batch size of 32. Model is training, and for the accurate results, models should be trained on at least 25 epochs, and for accurate and better results, models should be trained on 40 epochs, as GPU time limits also is there. So this is our training and validation loss, which is decreasing after every epoch, which is good. And this is a DCGAN generator, which can convert the images from sketches. This is our result. I can rerun it. As you can see, emit input images is input sketches is given, and predicted sharp images are given. They demonstrate the success of our GAN model in generating realistic face sketches, input sketch and generated sketch, good reconstruction of facial features, real clear edges and structure, good similarity to real image. Here we have evaluated our model by using FSIM, which is feature similarity indexing, and PSNR and SSIM, similarity and peak signal to noise ratio distributions, where the values showcase the accuracy and higher values indicating closer reconstructions of the images. As in the conclusion, the project aimed to convert the hand-drawn sketches into clear realistic images by using the PatchGAN and DCGAN system improves the image quality and captures the more important facial details more effectively than basic methods. Overall project achieves its goal of providing a reliable and accurate sketch to image synthesis approach that can support investigations. Thank you.